I've got a short video for you today about two topics. One is the range rule of thumb, and the second thing is using the coefficient of variation to compare if you have two data sets, which one is more spread out. So we're going to do both of those things in this video. So first of all, the range rule of thumb is a real easy calculation. You should not use this to find the standard deviation. You should use the big long method we learned in class. However, it can be used to estimate what the standard deviation will be, and I'm explaining it to you because some of the questions ask you to use it as an estimate. So do not use this in homework as an alternative to calculating standard deviation. Just know that it approximates the standard deviation. Also, it should only be used when data is unimodal and roughly symmetric. So if you remember when we had our histograms, it meant that the data looked something like this. It was unimodal and it was symmetric. So both sides of the data looked roughly the same. So here's what the formula is. A rough estimate of the standard deviation is this. Lowercase s, remember, is sample standard deviation, is approximately equal to the range, which remember, range is high minus low. So high minus low divided by 4. That's what it is approximately. Now, one of the things that you can use the range rule of thumb for is to estimate what the largest and smallest data values of the data set are. So you can estimate the smallest data value as x bar, which remember, x bar is the mean for a sample, minus 2 times S, which is the sample standard deviation. Okay? The largest data value, you take the same x bar and add 2 times the standard deviation. So what these formulas imply is that almost all of the data values are going to fall within 2 standard deviations of the mean. And so that gives us kind of like an estimate of the range of our data based on the standard deviation. Okay, the coefficient of variation. Now here's the deal. When you have two data sets that have the same unit of measure, standard deviations can be compared directly. However, the coefficient of variation allows us to compare the standard deviation when the units are different between data sets. So, for example, if we look at, we have for homework tonight numbers 9 through 11. So I want you to do two things for me. One is this. You are calculating data related to a group of men and a group of women in number 9. So you are going to be calculating the range, the variance, and the standard deviation for just the group of men and just the group of women. Now, since both data sets have the same unit of measure, you can simply compare the two data sets. So the larger standard deviation means the data is more spread out. All right, so let's write that down. Okay. However, if you happen to have two data sets that do not have the same unit of measure, you cannot just compare the two standard deviations. You have to use something called the coefficient of variation. Now, this is denoted as C-var right here. C, capital V-A-R. That is the notation for the coefficient of variation. And the way it is calculated is actually really easy. So it has two formulas, one for samples, one for populations. First of all, for samples, S, which is, remember, the standard deviation for a sample, divided by X bar, which is the mean, and then times 100. All right? For population, the formula is the same, just the notation is different. The notation for standard deviation is baby sigma, and the notation for the mean is mu. All right, now in number 9, since you have the same unit of measures, you do not need to calculate the coefficient of variation, but I think that you should as practice. The answer will not be in the solutions, however. Okay, let's go ahead and do an example using the coefficient of variation. Okay, sales of automobiles. The mean of a number of sales of cars over a 3-month period is 87, and the standard deviation is 5. The mean of the commissions earned by the salespeople is $5,225, and the standard deviation is $773. Compare the variations of the two. Now, you have to do this using the coefficient of variation. You cannot just compare the standard deviations because one is in dollars and the other is in number of sales. Remember, if the two standard deviations are in the same unit of measures, all you have to do is take the bigger one. That's where the data is more spread out. So it varies more. However, in this example, we have dollars and number of sales, so we have to compare the spread using the coefficient of variation. So here's our two calculations. So we've got number of sales and commissions. Remember, CVAR equals the standard deviation divided by the mean times 100. So here's what we've got. Standard deviation is 5. The mean is 87 times 100. This equals 5.7. Okay, we'll do the commissions. So once again, same formula. CVAR equals S over X bar times 100. So in this case, we have a standard deviation of 773 divided by the mean of 5225 times 100. This happens to equal 14.8. So here's what this means. It means that commissions are more variable, which means more spread out. Here's another example. Pages in women's fitness magazines. The mean for the number of pages of a sample of women's fitness magazines is 132 with a variance of 23. The mean for the number of advertisements of a sample of women's fitness magazines is 182 with a variance of 62. Compare the variations. So first of all, a couple of things you need to notice. They didn't give us the standard deviation. They gave us the variance. We need to find the standard deviation. So remember, standard deviation is the square root of the variance. All right? Okay, so let's go back to our formula. CVAR equals S over X bar times 100. So, in our example, we don't have the standard deviation, we have the variance. So our standard deviation is the square root of 23 divided by 132 times 100. This equals 3.6. Let's go ahead and do the number of advertisements. So again, and I actually recommend when you use a formula, write it out. It will help you to remember the formulas. So the standard deviation in this particular example is the square root of 62 because we have the variance, divided by the mean, which is 182, times 100. And this equals 4.3. Now, since 4.3 is bigger than 3.6, we would say the number of advertisements is more variable, so more spread out.